Possessed of an overwhelming desire to fly, Geoffrey de Havilland left the motor industry in 1908 and set about building an aeroplane. He was joined by another young engineer named Frank Hurl. Their first machine came to grief, but around the undamaged engine, these two men built an improved aeroplane, and on this, de Havilland taught himself to fly. These experiments led to a series of combat aircraft for the first great struggle with Germany, notably the DH-4 high-performance bomber. The DH-9 and 9A bomber reconnaissance, built in vast numbers, and a larger aircraft intended for bombing German industry, the DH-10. By 1918, a third of the Allied Air Force and 95% of all the American production were machines of de Havilland design. For 20 years, the team concentrated on civil aircraft. The DH-34 cross-channel liner of 1922. The DH-50, pioneer of Empire services. The Moth, that set a light aeroplane standard. The Hercules for the Cairo-Baghdad airway. The Puss Moth for private travel at 20 miles to the gallon. The Tiger Moth, trainer of the Empire. Dragon, for light traffic without subsidy. The DH-86 for the Imperial Mail, Singapore to Brisbane. The Little Comet, victor in the great race to Australia. The Dragon Rapide, champion of economy with the small load. The Albatross liner of 1938, which cut the London to Paris time to within the hour. The Flamingo all-metal liner, which first appeared on the London to Jersey service in '39. The DH-4 was a bomber with fighter speed, and it was the restatement of this principle a quarter of a century later which led to the creation of the fastest aircraft of its day in the world, the Mosquito. Munich, 1938. In those fateful days, de Havilland argued with his colleagues that if war should come, a valuable aircraft would be a bomber in which armament was sacrificed for speed, and that wood construction would save precious time and relieve the metal industries. As early as October 1938, Captain de Havilland and Mr. Walker approached the Air Ministry with these ideas. Meanwhile, the factory continued building very inoffensive aeroplanes. Tiger Moths by the thousand for training our greatly expanding Air Force. Dragon Rapides for auxiliary air traffic and for use as flying classrooms in the teaching of navigation. And Flamingo liners, a vigorous British bid for world markets thwarted by the war. The crash came. Germany fell upon Poland and made a brave show of bombing her defenseless cities. The idea of a bomber with fighter speed was again pressed forward. This was a revolutionary proposal, to fly a load of bombs across enemy country with not a gun to defend yourself. Would you really get enough speed to escape defending fighters? The mathematicians said you would. In the bombers of that time, armament represented a sixth of the loaded weight. Remove the guns, gunners and turrets, and all the extra fuel, and structure needed to carry them, build instead an aeroplane just big enough for a crew of 4 250-pound bombs, fuel for 1,500 miles, and it would certainly be 100 miles an hour faster, as fast as a fighter. The designers were convinced that there must be no compromise in this matter, no rear guns, no third crew member to be paid for by loss in performance. It must be a totally unarmed aircraft. The Ministry finally agreed to the building of a prototype, and design work began on the first day of 1940. In the secrecy of a country house, the design problems were worked out through anxious times leading up to the Battle of France.
This is the BBC Home Service. Here is the news, and this is Stuart Hibbard reading it. A large number of British and French troops have arrived safely from northern France. Allied forces are holding out round Dunkirk and on the line of the Yser. The air battle of the beaches at Dunkirk raged unceasingly all yesterday, while the withdrawal of Allied troops continued. At dusk, British fighter pilots had shot down 56 bombers and fighters. 42 of these were seen to crash into the sea. British fighters were heavily outnumbered, sometimes more than 5 to 1. 16 of our fighters were reported missing. Nearly a dozen air raid alarms were sounded.
The aircraft was urgently needed for reconnaissance as well as for bombing duties.
When the Lions region was bombed in the afternoon.
But when France fell, the defence of Britain put all thought of new designs in the background, and the Mosquito was dropped from the programme. The engineers argued that the Mosquito was a special case. If successful, it might well revolutionise the pattern of aerial warfare. It was to be built of wood and would make only slight demands on the metal industries which were being so hard pressed. Improved technique in the making of high-strength castings, for instance, had almost entirely eliminated forgings from the design, so that the material schedule showed light alloy castings totaling 250 pounds, but forgings a mere 30 pounds. Looking ahead, the Ministry decided to reinstate the Mosquito, but it was not to interfere with the company's more serious work, the building of trainers and the adapting of tiger moths to carry bombs as a rather pathetic last-minute measure for attacking the expected invader. The Battle of Britain rent the skies. In the daily air attacks, only once did a hit-and-run raider get a stick of bombs right into the works, causing nearly 100 casualties and destroying valuable materials. But in the secrecy of a barn-like hangar beside the old country house, the prototype was fast taking shape. Everyone noticed its resemblance to the Albatross passenger liner, which surpassed in purity of form the keenest fighters, and so combined speed with economy. Also to the earlier Comet Racer, first British aircraft to have a retractable undercarriage, wing flaps, and controllable pitch propellers. The Comet Racer, which won the Great Race to Australia, flying the 11,000 miles from Milton Hall to Melbourne, halfway round the world in 71 hours. The prototype was ready for test by November 1940, 11 months from the start of the design. She was covered with tarpaulins to hide her form from frequent German raiders. The technicians liked the look of her very much. A few straight hops, and off she went on her first flight. She was a joy to behold. She looked right, and she was right. de Havilland reported favourably to his father. In the height of the Blitz, craftsmen laid out the new job. Every component was hopefully drawn for quantity manufacture. These men collaborated with the methods engineers who contrived ingenious jigs and fixtures for speedy production. But hand methods had to be employed in the making of those first wooden components, which were soon to be standing up to such very great stresses. The strength of the Mosquito wing is in its built-up wooden spars and its double skin of birch plywood, cemented with a formaldehyde resin. For lightness and simplicity, the wing is made in one piece. Stress engineers test to destruction specimens of every main component. A section of the double top skin of the wing is compressed until it fails at a loading that represents 41 tons on each side, equal to 82 tons in the test of the complete wing. It could carry the weight of 700 men. Because the strength is largely in the skin, there is very little internal bracing, and this helps to make the aeroplane small for its load. The wing houses 10 fuel tanks, holding 539 gallons, weighing nearly 2 tons. The load evenly spread across the span. A mold is used in constructing the fuselage. First, the bulkheads are fixed into slots in the mould. Then the inner skin of birch plywood is applied, only 2 millimeters thick. An interlayer of balsa wood is fitted next, to act as a stabilizer between inner and outer skins. This balsa wood is a curious kind of tropical timber. It grows very rapidly and is the lightest wood in the world. Finally, on goes the outer skin, also of birch plywood. This is known as carapace or lobster shell construction, and like a lobster, the fuselage is served up in halves, a fact which greatly facilitates the installation of equipment, controls, bonding, hydraulic, pneumatic and electric lines. The undercarriage leg is a column of rubber blocks in compression, the last word in simplicity. It does away with all the precision machining of the more orthodox hydraulic leg. The radiators, oil coolers and cabin heater units, very necessary for high flying, are built into the leading edge of the wing, so as to preserve streamline. And this is helped by the fact that the Rolls-Royce engines have a small frontal area and a clean profile. The compact hub of the de Havilland propellers allows the blade shape to extend well into the spinner line. A wide range of pitch is necessary, and as a safety measure, the blades can be feathered to stop an engine from windmilling if it is damaged. The maker's trials were completed in 79 flights during 3 wintry months. She was as fast as a fighter, in fact faster than any other aircraft in the world. Highly maneuverable, tight on the turn, quick on the roll. From the first there were discussions about increasing the load. By cropping the vanes of the standard 500-pound bomb, 4 of this size, instead of the 4 250-pounders, could be housed in the same bomb bay, and so the designed load was doubled before ever the aircraft went into service. Meanwhile, a night fighter version had been hurried forward under pressure of the Blitz. The designers had provided for 4 20mm cannon in place of the bombs, which, together with 4 machine guns, gave a concentrated and destructive firepower. A bomber turned into a fighter, a thing unknown in modern aviation. On May the 15th, 1941, from a 450-yard field beside its secret hangar in the country, the fighter prototype made its first takeoff. Official interest now fully awoke. Of planned output was stepped up out of all recognition. The layout was lofted for much greater production. At the Canadian de Havilland factory, engineers from the home company arrived by air to organize the building of mosquitoes in the New World. In the great industrial towns of Old England, in hundreds of villages up and down the countryside, woodworkers, furniture makers, cycle manufacturers, engineers large and small, had adapted themselves to an unfamiliar and exacting industry, and were pouring out parts for mosquitoes. Soon there were more than 400 subcontractors, and nowhere could the enemy bomb out a vital flow. Deliveries to the RAF began in July 1941. By December, they had 20 mosquitoes. By March, 50, comprising reconnaissance, fighter, and bomber types. With the first rough and tumbles of active service, the ease of repairing the wood structure became important. Grafting on a wing end from stock was a simple carpentry job, requiring only plain butt joints. Then came a string of design developments. 2 500-pound bombs were fitted behind the cannon of the fighter, making it a fighter bomber. 50-gallon drop tanks were fitted to the wings to extend the range. These were made interchangeable with 250-pound bombs. "500-pounders were substituted, giving the fighter a 2,000-pound bomb load and the bomber version 3,000 pounds. "100-gallon drop tanks, and now made of paper, were fitted. 3/4 of a ton of additional petrol, giving an extra 600 miles of range. Early in 1944, Mosquitoes went into service which carried a single 4,000-pound blockbuster. This development called for only a slight alteration in the slender line of the little aircraft. She remained practically as fast as in earlier life. She was now transporting more than 4 times her original designed load. High-altitude engines and pressure cabins became available, making the stratosphere hers as well as the middle sky and the hedgerow. Along with the design development, production made progress in 3 continents. From the home factories, mosquitoes were now coming off the line in hundreds. They passed the first 1,000 mark within 3 years of the conception of the design. In Canada, the de Havilland factory got quickly underway. Their first Mosquito flew within 12 months of the engineers arriving from England. Winter and summer, they were flight delivered to the European war theatre over the Arctic wastes of Greenland and Iceland, and also non-stop across the Atlantic, repeatedly breaking the record with times down to 5.5 hours. In Australia as well, after Pearl Harbor, the de Havilland organization had been turned over to building Mosquitoes. Our friends down under also got their first aircraft into the air just a year after the initial parcels of drawings had arrived from the parent company in England. Exceptional maneuverability, the upward roll with one propeller feathered. Operational sortie was made on September the 20th, 1941, 21 months from the start of design. It was neither a bombing nor a fighting mission. A camera-equipped Mosquito set out, unarmed, photographing enemy harbors from a height of 4.5 miles. With high photographic skill and determined flying, the Royal Air Force developed long-range reconnaissance at plus fighter speed, something which the enemy was never able to achieve. All Europe thus came within the range of our cameras, which brought back pictures of microscopic accuracy that defeated every ingenuity of camouflage. The Tirpitz in her Norwegian hideouts, Königsberg, 1,000 miles from England, Taranto Harbour, the Messerschmitt factory at Wiener Neustadt, Bordeaux, rocket sites photographed from below ground level. With flashlights of 700 million candle power, photographs were taken at night. Thus were the enemy's night movements watched throughout the German retreat of 1944 and 45. From India and Australia, with round flights of 2,000 miles or more, the Japs were watched in Burma, Siam and Java. When the experts were forecasting the weather for British and American heavy bomber attacks, their late night final report, on which the plan of operations depended, was the one brought in by a lonely Mosquito on reconnaissance. The American Air Force built up its main reconnaissance wing on the same pattern and chose the same aircraft. The bomber in which armament was sacrificed for speed faces the test of reality. Its operational career began when 4 Mosquitoes bombed Cologne a few hours after the first 1,000 bomber raid. Dawn, May the 30th, 1942. on that first day's work, pilots could see that the best way to use such speed and maneuverability was to fly in at rooftop height, where neither ground guns nor radio location could concentrate upon them. The technique was perfected.
Well, now that's the position of the lamp and radio works at Dorminster. During the run up to the target, I'm going to try and aim for the left-hand side of the biggest building. And I want everyone to pack in as tight as they can there, and we'll all get across the target together. You look out for your formation flying there, Smithy. Now, I can't overemphasize the importance of these works to the Germans. So I want everyone to put forward their best effort to put the bombs right in the front doorstep. Okay, take it away. Now, chaps, remember what I told you in the briefing room? It's very hot today, so get off as soon as you can and catch me up. No one's to get below me crossing the sea, and pack in tight over the enemy coast. All right, good luck. See you later.
Good luck, sir.
Coming up. Something behind. Looks like a 190, about 1,000 yards away. Open up and go take out. What's happening now? Still there. Keep going. Okie dokie. They've given up. Miles away now. Gosh, we could have pinned his ears back if we'd had some guns. sweet home. They'd bombed the target, the whole target, and nothing but the target. British radio experts called for a fast aircraft capable of carrying their wonderful apparatus for bombing accurately through cloud. The Mosquito was chosen for the most important of this equipment, for it could fly far, fast and high without equal. The Pathfinder had to reach his target, maybe 600 miles from home, to the minute, and fly rock steady through all the flak before dropping his marker flares. This British achievement of brain and bravery made possible the accurate and utter devastation of the great arsenals of the Ruhr and Rhine, ever shrouded in industrial haze. From May 1943, Mosquitoes undertook nuisance bombing at night. Because of their speed, they lost only 11 aircraft in their first 1,000 sorties. By early 1944, they were carrying 4,000-pound blockbusters, and the big city was their favorite target. By now, this very small aircraft was carrying to Berlin a heavy bomber's load, unarmed and without need of an escort. It represented a small capital asset with a small crew, exposed to less danger because of its speed, and exposed to danger for less time. Yet it carried a 4,000-pound load and carried it more frequently than the slower, large bombers. Losses decreased to a fraction of 1%, and Mosquitoes grew to a ripe old age on the job, some of them exceeding 200 sorties. Night after night, Mosquito crews were briefed for this duty, seldom missing more than 3 or 4 nights a month in even the worst weather. High-altitude engines and pressure cabins enabled them to bomb from a height of 6 miles. This was no longer nuisance bombing, but systematic pounding by Mosquito blockbusters flying in strength, led in by their own Pathfinders. And up to the spring of 1945, they had delivered 15,000 tons. Much of this fell on Berlin, visited for 36 nights in succession. The other half of the battle history concerns the armed Mosquitoes. After the first blitz had been broken by our Beaufighters, Hurricanes and Defiants, Mosquitoes took over the night defense of Britain. Radio location did wonders in helping to find the enemy in the night skies, and Mosquitoes, now with improved equipment, got busy in 1943 when the enemy sent his fastest single-engine fighters to England with a puny bomb load, copying the Mosquito technique. But they failed, because our Mosquito fighters could catch these hit-and-run raiders. When the flying bomb attack started in June 1944, it was the Mosquito's job to destroy these missiles by night. They were far from easy to catch, but Mosquitoes got 620 flying bombs in the first and worst 9 weeks. Later, when the launching technique changed, they destroyed their launching craft as well. By the end of 1944, Fighter Command Mosquitoes had also destroyed no less than 660 enemy aircraft. Mosquitoes had been on ocean patrol since the winter of 1942, seeking out submarines and destroying the long-range enemy fighters sent to harass our bombers which were after their submarines that were after our shipping. A complicated struggle, this U-boat warfare. In 1943, the Mosquito was asked to carry a 6-pounder quick-firing gun. It was a field weapon, weighing nearly a ton and with a kick like a mule. This also entailed carrying half a ton of armor, steel plates up to 3/8 of an inch thick, to protect engines and crew in close battle with shipping or tanks. Meanwhile, the rocket projectile was developed. No gun to carry, no recoil problem, a more destructive missile. The rocket salvo of a Mosquito, 8 60-pounders, is equivalent to the broadside of a 6-inch cruiser. The anti-shipping formations were cunningly mixed. Fighters, 6-pounders and rocket projectile Mosquitoes, all in one strike force to sweep the decks and disconcert the shore-based enemy fighters. Accuracy is the nice feature of the 6-pounder, and it fires at the rate of 25 shells in 20 seconds. It was most effective against submarines and small shipping targets. Speed and maneuverability enabled the Mosquito to carry the chase into enemy harbors where the gunfire was hottest. Rocket projectiles were used with devastating results against larger ships. The use of Mosquito fighters and fighter bombers against land targets is a separate story. After some profitable trade from home bases, intruder business was opened up in the Mediterranean zone just as the 8th Army was driving towards Tripoli. From Britain, Malta, Italy, Sardinia, later from France, from India, from Australia, this form of aggravation gave the enemy sleepless nights. Intruding covered a wide scope and was undertaken by the Tactical Air Force and by fighter and bomber commands. Bomber Command used Mosquito intruders to support their heavy assaults in various ways, by escorting Lancaster and Halifax forces as fighter cover and by flying ahead of the main force to disorganize defenses. They lurked around airfields and shot down the enemy fighters on their own runways. From June 43, Mosquito intruders, working in tactical support of the Army, took over the specialized method of day attack previously used by the day bombers. They didn't all get off scot-free, and when a propeller had to be feathered to stop a damaged engine, it was sometimes necessary to jettison the wing tanks to regain a little of the lost speed. With undercarriage damaged, many a Mosquito landed sedately on its belly, in a cloud of dust and gas from automatic fire extinguishers. With the main entrance blocked, out come the crew by the fanlight. When the enemy was being driven across France after D-Day, single-engine intruders kept him pinned under cover by day. Mosquitoes smashed his troop movements by night. Aided by the light of flares, they were out in their hundreds, night after night, and wrought great havoc. Destruction. Scientists serve the need of the hour. When the need was destruction, British engineers accomplished this with unequaled efficiency and economy. Happier chapters will be written when this same skill is directed once again to the constructive purposes of aviation.